distributive property. And so notice it says to factor. And so as we did yesterday, what we would do is we would do this. We'd say, oh, well, I'm going to group these 2 and 2. There's one issue. Okay? And if I group these, it's not going to work. And this is the reason. Look at the relationship between 2 and 12. The relationship is that 2 times 6 is 12, right? Let's look at these. The relationship there is that 42 times what is 7? So if you notice there, it's not going to work because the relationship needs to be the same. So what I'm going to have to do here is I'm going to have to rewrite things a little bit. And so I'm going to go ahead and leave my first grouping the same. So I'm going to go ahead and leave 2mk minus 12m. And that's going to be my first group. And that shouldn't be a problem. My next group, though, what needs to happen there? They need to flip-flop. And then if I look at the relationship now notice the negative goes with the 7. If I look at the relationship now, 7 times what is 42? 6. So that's exactly what I wanted to have happen. So from this first bunch, what am I going to take out?
Negative.
What's in common with a 2 and a 12? 2. What's in common with an mk and an m? M. So if I take a 2m from 2mk, okay, minus, if I take a 2 from 12, what does that leave me with? 6. Anything else? No. So now if I look here, I've got a negative 7k and a 42. What is in common with negative 7 and 42?
7.
And why am I taking out a negative 7? So it's positive, yep. So if I take a negative 7 from a negative 7, that leaves me with 1k. If I take a negative 7 from 42, that's going to leave me with negative 6. Now, if you remember, this is our trick that we want to make sure those are the exact same. They are. So that is one factor. What is your other factor going to be? 2m minus 7. So that is what that factors to be. Now, times when you would probably want to do this. When you get down to this step right here and you find out that they don't match, you might have to go back and rearrange if you don't recognize it right away. So let's go ahead and look at this one. C minus 2cd plus 8d minus 4. So what am I going to do? Flip what? Flip the 8d and the negative 4. Why?
So it will come out with 2.
Look at this relationship. 1 to what? 2. This one, 8 to 4. It doesn't match. Okay, we've got to have a 1 to 2 relationship. So I'm going to rewrite this. And then I'm going to go ahead and group them. So what can you take out from that first group? C. And what does that leave me with?
Negative.
1 minus 2d. What can you take out from the second? Negative 4. And then that leaves me with 1 minus 2d. So what is one of our factors?
1 minus 2.
1 minus 2d. What's my other factor? C minus 4. Okay, I want you to try the bottom one. You try the bottom one for me. Okay, you should be able to look up on the board and check your answer and see kind of what I did. Okay, notice, all right, that I had to switch the 27 and the 18 because once again, 3 and 2, the relationship there, 3 is bigger than 2. Relationship between 18 and 27, 27 is the bigger, so we had to flip-flop those. So any questions over that type of factoring? Yes?
From 27 minus 18. And then that's when you hit the 9.
Yep, yep. Right here.
Wait, you're supposed to have the bigger numbers or the smaller numbers?
No, it depends on what the problem is. Okay, in this case, if you notice, 3 is bigger than 2, right? That's the relationship here. In this case, the 18 is bigger than the 27. Okay, now up here on this first one, we went with the relationship 1 to 2. Okay, and then this one was, and so it always depends on whatever type of problem you're given. Does that explain things better then? Good. Any other questions? Okay, then let's go ahead and look at what we're now going to do. Now what we're going to do is actually solve equations with this. Okay, so we first of all factored, now we're going to solve these equations. And so if you look at this, it says solve each equation, check your solutions. I will tell you that these first two are fairly easy. There's really not a lot of work. Okay. So what we're going to do is we're going to apply what's known as the zero product property. And what the zero product property states is if you have two quantities and that equation equals 0, that means that either this has to equal 0, or it means that this has to equal 0. Right? Because if you think about it, in order to get something to equal 0, it either has to be like 0 times 3 or 3 times 0. And so that's what we're doing here. And so all we need to do is solve each of those equations, and those will be our solutions. So to solve that, I'm going to subtract 6. Right? So I end up getting 2x to equal negative 6. What do you do now? Divide by 2. Very good. And so what does x equal? X equals negative 3. I'm running out of room there. So that's one solution. Now I got to do the same thing here. So what am I going to do first? Add 15. So I'm going to add 15 to both sides, and so I get 3x to equal 15. Now what do? Divide by 3, so I get x to equal 5. So what this is saying is, if I plug 5 or negative 3 into this equation, it will equal 0. It will. So let's go ahead and look at the second one. 3n times n plus 2 equals 0. So I'm going to apply the zero product property now. I have two quantities. The first quantity I'm going to set equal to 0 is what? 3n. So I've got 3n equals 0. That's my first quantity. That's right here. What's the next one going to be? n plus 2 equals 0. So I just need to solve each of those. So this first one, what do? Divide by 3. So I get n to equal 0. Or what do you do here? Subtract 2. So what do I get here? N equals negative 2. So far so good? Let's look at one more slide and we'll see how we... Ooh. Okay. Wow. Okay, so let's look at that first one. So that's a little different than the problem we just got done doing because it's not in factored form. Okay, what is an observation that you have on that first problem that we didn't have on the first two? Okay, it's squared. Let's think about something else. There's no 0. That's a big thing. There's no 0. So what I've got to do is somehow make a 0 appear. And so what I'm going to do is I'm going to get everything over to one side of the equation. So I'm going to isolate everything on one side of the equation. So when I do that, I get m squared minus 3m. That's going to equal 0. So there's where my 0 is. You've got to have a 0 in order to apply the zero product property. So then now I have two terms. I notice I've got an m squared and I've got a 3m. What's in common with those two? An m. So if I take an m from m squared, I get m, right? If I take an m from 3m, I get 3. So then now we need to use the zero product property. So I want you to quickly use the zero product property and solve that equation. Use the zero product property and solve that equation. You might not even need to write it down. You might be able to just write your two solutions down. So what's one solution? 0, right? Because this equals 0. So m equals 0, that's one solution. You can't do anything more than that. Or I have m minus 3 equals 0. But if I solve m minus 3 equals 0, what do I get m to equal? 3. Okay? All right, I want you to do the second one for me. 8n squared minus 40n equals 0. 8n squared minus 40n equals 0. 8n squared minus 40n equals 0. Very first step, you're looking for what's in common with the 8 and the 40. That's your very first step. So what is in common with the 8 and 40? The second step is to find out what's in common with the n squared and the n. So first step, what's in common with the 8 and the 40? And then what's in common with the n squared and the n? So what is in common with the 8 and the 40? 8. Okay. What's in common with the n squared and the n? N. So if I take an 8n from 8n squared, I'm left with n. For those of you wondering how that happened, 8 from 8, you're left with 1. If you take an n from n squared, you're left with n. So now I need to think 8 times what number is 40? 5. And notice your n is already accounted for, so you're done there. So then now you've got two quantities. Either 8n equals 0 or n minus 5 equals 0. So how do you solve this for n? First one. Divide by 8. So what do you get n to equal? 0. What do you get n to equal over here? 5. Okay. I want you to go ahead and do the bottom left for me. W squared equals negative 10w. W squared equals negative 10w. So what do I do first?
Add 10.
Add 10w to both sides. So I end up getting w squared plus 10w equals what? 0. Now I need to look at what's in common with the w squared and a 10w. So what's in common with those two? A w. So if I take w from w squared, it leaves me with w. If I take w from 10w, it leaves me with 10. So my two solutions will be what? 0 and what else? And negative 10. Now you could write them as, and maybe that's, sorry, I should have written them the other way. So either w equals 0, okay, or w equals negative 10. Alrighty, so now you should be able to finish your assignment that I gave you yesterday, 16 through 44, the evens. Now, I'm probably thinking we'll probably have a worksheet tomorrow, kind of to go over some of this stuff again. So for tomorrow, 16 through 44, the evens.